In quantitative research, the most prominent criteria for evaluation of quality of research are reliability and validity, and these are translated into various tools and procedures which concern sampling, measurement and causality in empirical models. This video introduces methods and techniques for quality assessment in quantitative research by showing how the general notions of validity and reliability are evidenced in quantitative research to show accuracy. What do I mean when I say that quality is evidenced as accuracy in sampling, measurement and empirical models? Let me start by returning to the concept of validity, which is concerned with the integrity of the conclusions that are generated from your research. In quantitative research, there are multiple facets of validity, including external validity, internal validity, phase validity, convergent validity, discriminant validity, and so on. For example, external validity concerns the question of whether the results of your study can be generalized beyond the specific research context. To use one of our example studies, a study of employee motivation in the context of Australian public sector organisation. Looking at the study, we ask ourselves if a study of motivation based on Australian sample of public sector employees can inform our understanding of the motivation in general in all and any employees, anytime, anywhere. This is the question of external validity, and the question surfaces mostly in sampling, and non-randomized sampling designs pose a threat to external validity of findings. I'll come back to this point in a moment. By contrast, phase validity is the extent to which measures reflect the concepts of interest. Constructs have phase validity when they measure what they are supposed to measure, and this is judged by theoretical definition, references to past literature, and prior conceptualizations. The issue of phase validity and other aspects of construct validity is associated with operationalization of constructs and emerges in measurement, and that's where you would find indicators of quality. Finally, internal validity relates mainly to issue of causality and is concerned with the question whether conclusions that incorporate causal relationships between two or more variables are valid. For example, if we suggest that X causes Y, can you be sure that if it's not Z that is really responsible for variation? This something else, another unaccounted for factor, may be producing causal result. Similarly, you need to eliminate spurious relationship. For example, although ice cream consumption may be correlated with suicide rate, there is no valid theoretical explanation that links the two. Internal validity affects empirical models and is evidenced by having a sound theoretical model that includes all known factors that may produce result. There are plenty of techniques that assess validity and reliability in quantitative research, and it is useful to think about them in terms of three broad camps: data collection, measurement, and hypothesis testing, or in other words, techniques found in sampling, in measurement, and in and around testing of empirical models. Concerning sampling, the key issue is external validity and the question of whether the results can be extended beyond your sample. The various threats to validity in sampling bring about errors or biases, where the error is the difference between your findings and the true value in the population. There are two types of errors found in surveys: sampling errors, or errors related to the way you drawn the sample, and non-sampling errors, that is, the errors related to data collection procedures. Sampling errors occur because your sample will always be different from the population of interest. How much different depends on the type of sample you've used, the type of your sampling frame, and the size of your sample. The larger the sample, the smaller the error. The non-sampling errors include all the problems related to data collection and include fieldwork errors and respondent errors. To be considered high-quality research, your design has to account for the different errors and for your strategies of minimizing them. For example, larger samples are better because they control for variability better. Your questions have to be constructed in such a way as to reduce misunderstanding or guessing or attention lost. That is, reduce all unintentional errors in response. The reversed questions that we've seen in previous tutorial are one technique that is aimed at reducing error. One signal of quality typically included with reference to sampling is non-response or failure on the part of respondent to take part in a survey or answer specific question. We typically assess the scale of this problem by looking at response rates, that is the percentage of the total sample which completed the questionnaire. Saunders et al. Offer an excellent treatment of response rate, including its calculation. In measurement, the key aspects of accuracy concern the validity of constructs and reliability of measures. The validity captures the extent to which your measurement items, the questions you've asked, actually reflect the theoretical constructs of interest. These relationships are demonstrated by providing a definition for each construct, the sources of measurement, and referencing previous studies that have defined the construct in the same way. Reliability is concerned with the issues of consistency of measures and involves three prominent factors: stability over time, internal reliability, and inter-rater or inter-judge reliability. Measures are reliable when they produce the same results for the same respondent over time. The best assessment of reliability would be to show stability over time by testing and retesting respondents on some measure of interest, for example, their motivation. However, because in management we tend to test at one point in time, that is, we use cross-sectional surveys, we tend to use internal consistency as a marker of reliability. Internal reliability or internal consistency measures the extent to which the respondent rates related questions in the same way. For example, internal reliability would be demonstrated if respondent rated similarly questions that measure satisfaction, for example, by consistently ranking a set of questions as either high or low. Internal reliability is measured by Cronbach alpha coefficient, and in structural modeling there are two further measures: average variance extracted and construct reliability. For details, I will refer you to the advanced seminar on structural equation modeling. A special type of reliability that is found in both qualitative and quantitative studies is the inter-rater or inter-judge reliability, which involves the degree of agreement between independent judges or raters. Inter-rater issues occur, subjective judgment is involved in activities such as recording observations or translation of data into categories when coding is involved. In such instances, inter-rater reliability allows you to show that the coding process is valid, i.e., that the judges are assigning the same code to the same textual data, thus providing consistency and validity of the findings. Finally, in empirical models and hypothesis testing, you are preoccupied with the question of internal validity, the issue to what extent the relationship that you are discovering are valid and there are no alternative explanations. Concern with internal reliability is one reason why you would include control variables. For example, if you know that organizational size is a factor affecting performance, you would include size as a control variable alongside other measures, for example innovation or advertising, because they are also known to affect performance. Internal reliability can be evidenced from equations and statistical parameters of your models, but also from your conceptual model. In your conceptual model, you have to prove that you have created a coherent, theoretically based model that includes all aspects and all influences on a particular construct, and also excludes everything that doesn't affect it.